What's up? What's up? It's your man Jimmy Chan. Today we're talking about quadratic equations. So with quadratic equations, you have a standard form. And the standard form is ax squared plus bx plus c equals 0. Okay? So you got three different methods here. To solve. So remember, we're solving because there's an equation. So the first method would be factoring. And not every single one you're going to be able to factor. So remember that when we started doing the second and the third method, what would start to happen is that we start getting i's and not perfect squares. So factoring is for particular type of problems, okay? And then method two is completing the square. And method three, is the quadratic formula. So me personally, I know that factoring is not going to always happen unless if I can physically see that something's factorable, then I'll use factoring. I like completing the squares over the quadratic formula, but if you guys remember correctly, when I taught the quadratic formula, I always taught it with a song. So you'll probably hear me sing with a bad voice. All right, so let's use one particular equation and we'll go through all three methods. In fact, this is what we're gonna do too. So I'm gonna keep the factoring that color, and let's do that one that color, and then we will do the quadratic formula with that color. There we go. All right, so here we go. So let's first talk about factoring. So with factoring, there's two ways of factoring, right? So one is going to be their trial and error. And the other one is going to be your AC method. Okay, so I'm going to show specific steps for the AC method here. And with trial and error, well, I'm going to leave that on your own, or I might even show you a little bit of it too here. Let's say, for example, we have 2x squared is equal to 9x plus 5. So if you notice that the standard form up there, I got everything to one side and 0 on the other. Now, it doesn't matter which side you put it on. It does not. So what I would tell you to do is look for the x squared, and essentially what you're trying to do is get the x squared to be positive. So in this case, the 2x squared is on the left side, it's positive, so let's bring everything to that side. So what I would do is subtract the 9x and subtract the 5. And what I would get is 2x squared minus 9x minus 5 equals 0, which means that my A is equal to 2, my B is equal to -9, and my C is equal to -5. In fact, I'm going to bring this all the way over here so I can show you the AC method. All right, so the AC method, step one, excuse me, is to find my two numbers. So I got A times C, which is equal to 2 times -5, which is equal to -10. My B is equal to -9. So what I want to try to do is to find two numbers, obviously the same numbers, where if I multiply, it will give me -10, but yet if I add them together, the same two numbers added together will give me negative 9. So let's think about that a little bit. Think about that a little bit. And what you're going to realize is going to be negative 10 times a positive 1 is going to give me negative 10. And negative 10 plus a 1 is going to give you a negative 9. So there goes my numbers. All right. So step 2 is to use negative 10 and 1 to split the middle term. Okay, so what do I mean by middle term? So let's do this. Let's highlight that so that we can turn it to a color. Let's go with the light blue. And then I'm going to also highlight or change the color of what that middle term is, which is that negative 9x. So here we go. So I'm going to rewrite the 2x squared, but I'm splitting the middle term, which is that negative 9x, to negative 10x plus 1x and minus 5 equals 0. So the negative 10 and the positive 1 came from the first step, which I'm going to use to split the middle term. Step 3 is factor by grouping. All right, so factor by grouping is where we would split or separate, I should say, the first two terms from the last two terms. And then what we're going to do is we're going to factor each of those two terms separately. So we're only going to focus on just the first two terms. Let me see if I can make it work. Nope. So the 2x minus 10x, 2x squared minus 10x, we're going to factor by itself. And then we're going to factor the last two terms by itself. Then we're going to factor everything together. So let's see what's the GCF of that first group, which is going to be a 2x. And what does that leave us? That's going to leave us with an x minus 5. Then I look at the second group, right, which is that group right there. What's my GCF there? There's really no GCF. So at least I'm going to take out a 1, a positive 1. And what I have left is just the x minus 5 as well. So then we're going to factor as a whole. So we're looking at those two sides right there and saying, what do we have in common? And you're going to say, well, the x minus 5 is in common. Awesome. What do we have left? We have left the 2x plus 1. Okay. Then we would, the fourth step here, well, that's the factoring part. So the fourth step now is to solve. So to solve, what we're going to do is we are going to take each factor and set it equal to 0. And the reason why we're doing that is that x minus 5 here is actually a number. And the 2x plus 1 is actually a number. So in order for two numbers to multiply together to give you 0, one or the other or both numbers has to equal to 0. So what we're going to do is we're going to take the x minus 5, set it equal to 0. And then take the 2x plus 1 and set that equal to 0. And solve that separately. So we're going to have x equals 5. And then we're going to have x equals negative 1/2, where we subtracted the 1 over to the right side and then divided by 2. So therefore my answer here is x is equal to negative 1/2, comma, 5. There we go. All right. So that's how we would do the AC method. All right, so that's how we did the AC method. So the trial and error, so what I'm gonna do now is that I'm gonna take that standard form, I'm gonna keep that standard form as I go. So let's go ahead and look at trial and error. Okay, so this one right here, I'm gonna say, this is the AC method. Now I'm gonna do trial and error, okay? But I'm gonna bring that equation that's already in standard form down, which is 2x squared minus 9x minus 5 equals 0. Let me double check. It is. All right. So with trial and error, what I have to remember is that if I was to multiply, what I do know is this. In order to get a trinomial, it'll be a product of two binomials. Okay? So let's say this is A plus B and C plus D. Okay? What I know is that this first term is the product of these two numbers here. Okay? So what I got to do on the trial is saying, okay, so I'm going to draw my parentheses. So in order for A times C to become 2x squared, I have a 2x and an x. Okay? So that's what I want to do. And then what else I got to remember is that my last, -5, is a product of B and D. So let's say I call that, you know what I should do? I should just, because those are lined in green, I should make them green. Okay, and then the orange is a -5. So let's say I go, okay, it's 5 and 1. Now, I have my first and my last in good, in terms of the product of those are good. However, I have to check my outers and inners. So let's use this color right here. So this right here is the sum of the product of the inner and my outer. So the question is, if I use the 5x and the 2x, can I get a -9x? And the answer is no. So with 5x and 2x, I could get 7. Or if they were both negative, then I can get -7. If the 5x was negative, I can get a -3x. Or if the 2 is negative, then I get a +3x. Okay? So no way I can get 9. So therefore, what that means is that these two are not in the right position. So I had to reposition them and try it again and do it that way. Okay? So my inner is now 1x and my outer is a 10x. Can I get a -9 from that? And the answer is yes. If the 10 was a negative. Well, if 10 was a negative, then that means this would have to be a -5, and this would have to be a +1, because I want +1x. So that is the reason why I would have the same thing as up here, okay? So from there, I can go, all right, so I tried, I erred, I tried again, and now I got it. So now I can go, okay, so this is 2x plus 1, times x minus 5, and that's equal to 0. So then I set each factor equal to 0. So therefore I got x equals 5 and x equals -1/2, which is again the same answer. And if you notice that up here, the 5 came first, the negative 1/2 came second, but we still wrote the negative 1/2 first and the 5 second, because when we list those numbers, we have to put it in numerical order, okay? All right, so we are done with factoring. Now let's get to completing the square. So method 2. So let's go ahead and write that down. So the example was 2x squared minus 9x minus 5 equals 0. Okay? So the very key part about completing the square is going to be, the very key part is that a has to equal to 1. Okay? So with that case, I'm going to have to divide everything by 2. That will make the a in front of the x squared to be 1. So I'm going to have this. Now, x squared minus 9/2 x minus 5/2 equal 0. And that's typically why I call it step 1. Step 2 is to move, which I would call the old C, to other side. All right, so therefore I have x squared minus 9/2 x equals positive 5/2, right? In order for me to move that negative 5/2 over to the right side, I have to add 5/2 to both sides, okay? Step 3. Step 3 is to find a new C, which is equal to b divided by 2 squared, okay? Which this b is going to be the negative 9/2 divided by 2 squared, okay? So this right here would be my b. Okay, just like ax squared plus bx plus c equals 0, right? So there's my b squared. Okay, so now I have to do this part. Let me see where I'm at here. Okay, that's about where I want to go. So this is going to equal to negative 9/2 divided by 2 is going to give me negative 9/4 squared, which is equal to 81 over 16. All right, so okay, so I want to find a new c and add it to both sides. So what I'm adding here is going to be the 81. Let me just rewrite that, it's easier. Over 16 and add 81 over 16 on this side. All right. Then step 4 is going to be factor the left side and add or subtract the right side. All right, so I got to factor the left side. So the left side is going to be factored in this way. It's going to be x minus 9 over 4. And then add or subtract the right side. Well, I don't have common denominators, so I need common denominators. So what do I need to do? I need to multiply the bottom by 8 to get 16, so I got to multiply the top by 8. So I'm going to have a 40 over 16 plus an 81 over 16. So I'll rewrite this here. And if you notice, what did you notice here? Did you notice that that was orange? Because that was orange? So if you would just do the work here and get this, you will get the left side factored much easier. You don't have to really think as much, okay? So let's rewrite this. So this is again x minus, minus 9 over 4 squared is equal to 121 over 16. So now step 5 would be to solve. Not solve. Solve. Okay? So in order for me to solve this, I have to take the square root of both sides. So let me go ahead and rewrite all of this again. I guess I don't really have to. Let me do it this way though. All right, so I'm going to take the square root of both sides. However, when I take the square root of the right side, I have to remember the plus and minus. Okay? So what's going to happen here? The left side is going to just be left with x minus 9/4 is equal to plus or minus, and the square root of 121 is 11, and the square root of 16 is 4. Okay. Then I have to bring the 9/4 over to the other side. So now x is going to equal to positive 9/4 plus or minus 11 over 4. So now I actually have two regular fractions. That almost doesn't look like a 4, so let me make it look like that doesn't look like a 4, so let's make it look like a 4. There we go. All right, so now we actually have two answers. We have one answer, which is 9 over 4 plus 11 over 4, which is equal to 5. And then the other answer we have is 9 over 4 minus 11 over 4. So that's what the plus and minus means. So that's going to give me a negative 1/2. So again, different method of solving for it. However, I end up with the same exact answer. There you go. Okay. So now let's talk about the third method, which is the quadratic formula. So the third method is the quadratic formula. And the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. All right, so let's bring back that example again. That example is 2x squared minus 9x minus 5 is equal to 0. All right, so now I have a is equal to 2. My b is equal to negative 9. And my c is equal to negative 5. So all I have to do is plug it in. So that means I have x equals negative b. So if you think of this, this is negative 9 plus or minus the square root of b squared. So if I square the b, it's going to give me 81 minus 4 times a times c, and my a is 2 My C is -5. And that's going to be all over, and it's all over 2 times A. Okay? So my recommendation is that if you're going to put anything in your calculator, you ought to put just everything I highlight. Not the radical. Don't put the square root in there. Just do the 81 minus 4 times 2 times -5. Okay? So what we're going to have is this. We're going to have x is equal to minus 9 is going to be not positive 9. Oh, I'm sorry, minus a -9 means we have a positive 9. Plus or minus the square root of 121 all over 4. So that means x is equal to 9 plus or minus 11 over 4. Since these three are regular numbers, I again have two results here. Okay, so I got 9 plus 11 over 4, which is equal to 5. And we have 9 minus 11 over 4, which gives you that -1/2. So again, different method, same answer. And there you go. That squiggly bracket looks kind of too squiggly for me. Okay, and there we go. So same equation that we use all the way through, right? So remember that we always want to get everything to one side so that we have a quadratic equation or a standard form of a quadratic equation. So get everything to one side, make sure the square term's first, the x is second, the number is third, right? So I have ax squared plus bx plus c. And then so we have the factoring, which is either the AC method or the trial and error. We have the second method, which is the completing the square. The biggest part is that a has to equal to 1. So that's why we got to divide off that a to everything so that a would equal to 1. All right. The hard part about this is the factoring, but if we do the work over here, we'll find the factoring. All right, makes factoring a lot easier. We know what we got to add to both sides, and then we'll get our result. And the third is the quadratic formula. The tough part about quadratic formula is that you have to remember the correct formula. So I would suggest that maybe you go on YouTube and type in quadratic formula song. If you do that, then there's going to be a gazillion videos of different quadratic formula song. So one of my workmates or teacher mates that taught across the hall from me back in high school sung it with the Notre Dame fight song, and that's what's been stuck in my head ever since. So it's been a long time, but it's been stuck in my head, so that's always the same song that I kind of go with. So I would suggest that you get a song in your head with the quadratic formula so it's easier to remember. I hope this helps. If there's any questions, let me know. See ya.